Hi, this is Ambasam, Assistant Professor at SNS College of Technology. Happy to see you all in the next video, right? So today we are going to discuss about the process, the continuity of the previous video. Like we have seen a lot of things happening in and around. So today we are going to discuss about the sensors in the humanoid robots. So sensors in the humanoid robots is normally categorized into various types, and these are depends upon the actuating mechanism if they are needed. So as I said that on the sensors, right? The sensors always gives an input to an human values, humanoid robots. So sensors can be classified accordingly to the physical process which they work or according to the type of measurement and the information they given as an output. So based upon that, the sensors are categorized into several categories, mainly upon the three categories: state, energy, and touch. So state means perceptive properties, right? So normally the perceptive properties are sensing properties like a battery level, beat coder, and what are the ranging sensors they are using in the industrial purpose. The extractive sensors are used to enable the sensing external properties like mission, ranging, and the input sounds. These are can be used by. Similarly, the energy. So energy is depend. We have seen in the physics, right? Active and passive energy. So active always is emitting energy. Like what is the sonar, LiDAR, structural lighting, the human touch. These are the energy we are giving. The robot are going to give outside. Similarly, it has to receive energy like from the rays through human vision and hearing sensings. These are can be used by using an edge. Apart from the touch arm, so either contact or non-contact, these type of sensors are used to detect the object whether it is presence or not, and also we can able to see without presence is by using without touch properties. So as I said that earlier, on perceptive sensors are also a sense of self internal state. So measures value internally to the system. Example, battery level, wheel position, joint angle, speed are measured by using perceptive angles. Extraceptive angles are observation of robot environment objects in it. Some examples of these sensors are abstractal sensors, geographical sensors, light intensity monitors, etc. So these sensors and robotics are especially categorized into different categories, as I said, like external sensors, or sonar, range sensors, cameras, GPS. These are going to be in XSS value, but internal values are perceptive sensor encoders, accelerometers, gyroscopes, where the object, the rotation of joints, and what the value has been given. These are can be explained by using these type of sensors. Apart from that, visual slam refers to the problem of using images as only source of external information. They are doing based upon that criteria. So this is how the sensors. As we discussed, this is the detailed description. The precision sensor sense the position, the orientation, and the speed of the humanoid body and joints. The humanoid robots usually accelerates to measure the acceleration from which velocity can be calculated by integration. Similarly, tilt sensors are used to measure how much inclination it has been obtained. And force sensors are placed in a robot hand and feet to measure contact force between the environment. And also similarly, position sensors to indicate where the object is really available, positioned, from which the velocity can be calculated by derivation or even the use of the speed sensors. This picture represents the various commands or information interaction with ground energy. These are the contact points where the entire data has been obtained of the humanoid's body and joints. Similarly, for extraoperative sensors, gather information from environmental such as these sensor, obstacle sensor, geographical position, light intensity monitors, etc. So the tactile sensor provide information about forces and torques transferred between the robot and their objects. Vision sensors work mostly similar to the eyes of the human beings. Most human robots use CCTV cameras as an vision sensors. The sound sensors allows human robots to hear speech and environmental sounds and perform the ears of human beings. So similarly, the microphones are usually used for this task, but the sound sensors of human robots has to be placed in a vital role, right? So they are used. These are the general classification based upon different type of sensors, and the sensor system in the robotics are based on the extraoperative sensors. These are the glances where in these type of sensors are especially used, especially in the vision-based sensor. CCD or CMOS cameras were used for visual ranging packages and also for object tracking process. Apart from that, aiding sensors like compass, gyroscopes, inclinometers are the important sensors in humanoid robots. So by sensing these kind of things, the robot has to give an actuator mechanism, right? So actuators are the motors that are responsible for motion and humanoid robots are constructed in such a way that they mimic the human body. So they use the performing the muscles and joints through with different structures to achieve the effect of the same human motion. And the humanoid robots are usually mainly use rotary actuators. So they can either use electrical, pneumatic, hydraulic, piezoelectric, or an ultrasonic sensors. These sensors are used to produce the movements in an accurate manner within micro level sensors and also using the frequencies. This is how pneumatic, and similarly, this is how the mechanism has been done by extracting the value by using the internal sensors, and through external sensors, they are going to actuate the mechanism. This is about the humanoid robot, the humanoid robot sensor classifications and how it has been developed. So I think some overview has been given. And till next video, we will see afterwards. Up to that, bye bye, tata. Signing off, my Samasam, Assistant Professor, SNS College of Technology, Kanpur. Let's see you in the next video. Thank you so much.